All right, let's jump into our notes here. We're going to be classifying solids here, some three-dimensional shapes. Okay, let's start with a rectangular prism. This is what we'll use most this week. On the rectangular prism, when you draw it, like the picture over here, what you're really drawing are the edges. Okay, so that's what we draw. And what an edge is where two faces meet. Okay, so faces then are each of these. These are my faces. We'll call them bases later. Okay, so how many faces does a rectangular prism have? Well, think about a dice. There are 6 faces. There's a front, a back, a top, a bottom, right side, left side. Okay, so then edges. Where do the faces meet? Well, we've got 1 there, 2, 3, 4, 5, 6, 7, 8, 9. We see 9, and then there's 1 over here, 1 back there, 1 over here. No, there's not 1 there. 1 over here. So the total number of edges are 12. Okay, and you could, if you had a three-dimensional shape, you'd see that easily. Okay, then our last word is our vertice. When we think vertices, some of us think of corners. Okay, the corner. So it's where the edges meet. So that's a corner. There's a corner. 3, 4, 5, 6, 7. There's 8. 8 vertices. Okay, so let's look at a cube now. What's a cube? Well, it's a rectangular prism, but every side's a square. So it's the same. It has 6 faces, and all 6 faces are the same. So it has 6 square faces. It has 12 equal edges, since they'll all be the same. And again, it still has 8 vertices. Okay. So that would be a square, and you can see what the net looks like of this compared to the net of all rectangular prisms. A cube is one specific type. Okay, so what would be an example of a rectangular prism? Like a cereal box. An example of a cube. A dice. Well, you say 2 dice. 1 die. That'd be a cube. Okay, next we have a triangular prism. Okay, now looking over here at our picture, a triangular prism has 1, 2, 3, 4, 5 faces, but we also say that it has bases to it. Okay, so it has 5 faces, 2 triangular bases, and then 3 rectangular faces, as you can see by the net over to the side. So the net takes the 3D and makes it 2D. All right, let's look, as opposed to that, a rectangular pyramid, the next one here. Okay, now the rectangular pyramid has 4 triangular faces, but it has 1 rectangle base. Here's my rectangular base. So the base is a rectangle. Okay, so the difference between a prism and a pyramid, a prism has 2 bases on opposite sides parallel and also congruent, where a pyramid just has 1 bottom base. Okay, so next we have a square pyramid. So like a rectangular pyramid, but it just has a square as its base. So the base is a square. It still has 4 triangular faces. Okay, so then we have a triangular pyramid. Well, a rectangular pyramid had a base as a rectangle, a square pyramid had a base that's a square, a triangular pyramid has a base that's a triangle. Then it has 3 triangular faces. If you look over here, they're all the same. It doesn't necessarily have to be equilateral. This one is. Okay, then we have a cone. A cone we could also call a conic pyramid. It has a base that is a circle. Interesting how the net looks. 1 circular base. That's different than a cylinder, my next word. A cylinder is a type of prism because it has 2 bases that are circles. and then it has one curved face. It curves around, even though over in the net it looks like that, and you can figure out why. It is circular. Okay, and then last we have a sphere. It's just one curved, round surface. We think of a ball as an example. Okay, and as you know from social studies, you can't make a net out of it because you can't take a round object and lay it flat. Impossible to do. If you've ever tried to do that with an orange peel, it doesn't work. Okay, so let's come up with some other examples going back here. A triangular prism, where do you see that? Well, you could see that with a, well, just a prism, right? A rainbow prism in science when you use a prism. A pyramid, well, just the pyramids in Giza. An Egyptian pyramid, right? Square pyramid, same way. A triangular pyramid, you don't see these very often outside of like games where you have some dice that are like that. A cone, you can think of like an ice cream cone or a waffle cone or those cheap cups, because those are pretty cheap and easy to make to fill with water. Okay, and then a cylinder would obviously be like a pop can or something like that. Soup can. All right, next part of our notes. We're going to just do real basic finding surface area of just rectangular prisms today. Tomorrow we'll do much more advanced than this. Okay, so what is surface area? Surface area is the sum of the areas of all the faces. Okay, so all of these solids that we have are three-dimensional. It's the two-dimensional. It's the sum of all the sides. So a rectangular prism has 6 faces, we said. We only see 3 faces here. We see a top, we see a front, and we see one side. I'm going to call it the right side. Okay, so the area of the top here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're doing area, not volume. There's 10 there. The front, there's 1, 2, 3, 4, 5, 6, 7, 8. And then the right side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 15, 18, 19, 20. Okay, so I just counted. There's faster ways to do it, and we'll get into those. But right now, okay, so these are square units. 10 square units, 8 square units, and 20 square units. Okay, so each of these 3 faces has a face opposite that is equal. Okay, so the opposite of my top up here is the bottom. So if the top is 10, the bottom is 10. The opposite of the front face is the back face. And we said the front was 8, so the back is 8. The opposite of my right side, which we said was 20, is the left face. So that's going to be 22. So the full area of this rectangular prism, we have to add the areas of all the faces. So now we have to go back and we have to do 10 plus 8 plus 20 plus 8 plus 20 plus 10. We add them all up. Or we could add what we see, and we'll talk more about that tomorrow, add all these up, 38, plus add what you don't see, 38, for a total of 76 square centimeters. I know I messed up my labels the whole time. I put units. I should have put centimeters. If you want to go back and change them, you can. Square centimeters. I'm not going to make you do that right now. All right, that's an intro into finding surface area of rectangular prisms. We'll spend more on that tomorrow, and on classifying solids.